My name is Dan, and I'm with Spatial Business Systems, and welcome to the SDS-P4A demo today. We're going to talk about the Substation Design Suite product Physical for AutoCAD, which we abbreviate P4A, and we're going to be covering our product version 8.5.4. In today's demo, I have a few quick slides to briefly highlight the Substation Design Suite and P4A before moving into the P4A product environment. Our agenda today in our demo will be covering the following: feature placement in the 3D model space, in the P4A model space, 2D sheet creation. Now this is a new process that's being developed, and it is incredible. It's such a time saver, and well, you'll see when we get into it. It's one of the newer things to P4A that's really awesome in my opinion. We'll be talking about several new commands that help and aid in sub-design practices and saving time, design time hours, like XREF, the new AUDEXTRACT command, which is another new great command, the AUD copy-paste, the IEEE rolling sphere, lightning protection method, model swapping, and design validation, resolution tools, bill of material tracking. We're also going to be talking about the geolocation of our P4A drawings and creating civil 3D surfaces. So the Substation Design Suite, commonly known as SDS, of course, is a product that's been around since 2013 in one form or another. The suite has multiple products, but is divided into two disciplines. We've got the physical and protection and control. On the physical, we began with our physical substation design tool based in Inventor. Then in 2021, we introduced an AutoCAD-based physical design tool due to customer demand. And on the protection and control side, we have our PNC toolkit that's based on AutoCAD Electrical. So P4A is a rules-driven, model-based design. If you had to say, what is P4A, in just a sentence? So in other words, P4A sits on top of AutoCAD Map 3D, which then sits on top of core AutoCAD. That allows users to build a substation in that three-dimensional environment where each physical component or feature has both model data attributes and the geometry. So we could say a feature, whenever I say a feature, we're talking model data plus the geometry. And that data lives in the industry model shown in the lower left of the screen there within P4A. And next to that, we've got a list of standard materials that are stored in a material catalog. The part editor is where our 3D part blocks live. They can be edited and tied to information models. And we provide a rules engine as well that allows you to script and automate different actions. These rules somewhat determine how the program behaves, quote unquote. Within the P4A environment, it's simple to pick things from the ribbon menus and place them and connect them to other components, almost like in a Lego-like fashion. I'll get to that here in a second. But just one more quick thing to note here. I know it's a busy slide, but P4A primarily uses predefined models. So it is not a model creator like Inventor. However, SBS does offer a program called INEX, which works with Inventor to create the 3D models, and then we can import them into P4A. All right, enough of the PowerPoints. Let's go ahead and get into P4A and its model space. All right, so we have P4A open right here, and we have a couple of different things I want to highlight here. We've got our model space, our properties panel. There are a few ribbons across the top that we'll get into, where we can get into selecting our geometry and our model data. But first, we'll get into a few of these as we go along here. But first, let me show you just some simple, let's place some of this geometry down. All right, up here at the top, underneath the Substation tab, we have our major equipment, where we list different major equipment pieces like power transformers. We've got PTs, CTs, breakers, disconnect switches. I'm going to go ahead and set a breaker down. and we will align this, try to align this right on the center point here. Select our orientation, and just like that, we've dropped a feature down. Now this feature does contain the physical geometry itself, but also if we run over to our dashboard here, it will contain the model data all right here, and that's where we show the model attributes, the feature attributes, and we'll get into this in a little bit. But let's say we've got our breaker down. We want to put a foundation pad. Well, this can easily be done in P4A as well. And this is where I want to highlight a few things here. Now, as we rotate this over, you can see here, before I slap this down, there's this blue little port here. There's another port here on the breaker. When we look at the top of the breakers, we can see we have additional ports as well at the end of the insulators. These are what we call ports. And when we have our AUD 3D ports selected, this enables us to snap features together very easily through our ports. And it allows the connectivity and containment to occur from feature to feature. And let me explain. So as we hover over this port here, you can see we get this little yellow arrow pointing in the up direction. And then a box pops up, and it shows, PCB 138 kV circuit breaker. And this is showing that this foundational pad that we are connecting is being connected and contained by that breaker. And we can get into connectivity and containment here in just a second. So I place this guy down. When I select our breaker, I go over to our dashboard. You can see here now, we have a feature tree, and this shows the circuit breaker and the pad itself. So right now it's showing that this pad is contained within this circuit breaker. And this is important when we talk about reporting and keeping track of how these features are connected. If I were to move that breaker, now that the pad is contained to it, the pad will move with it, and it'll keep all that same connectivity and containment information. There's a couple different icons that you'll see when we hover over that tooltip that popped up, and we'll see that as we go. The two different symbols you'll see is this little knuckle symbol right here, and this is the connectivity little symbol, and this shows it's kind of like a bone joint or something. It shows that you're connecting these two features together. And then this circle within a circle is the containment. So this breaker, this pad is contained by the breaker, and we'll get into how that is important as we go along here. But one quick thing to note, I see that the conduit punch outs on our foundation are not aligned with our breaker. On the underside, we want to make sure we align that with the conduit knockouts for our breaker panel. So this can easily be adjusted by selecting the foundation. We'll go to our dashboard, and again, there's that containment. It's showing that that pad we just selected is contained by this circuit breaker, and when we hover over it, it highlights. So we'll go to the Attributes tab. We have an object rotation along the Z-axis, and 180 degrees later, and now we're aligned to this breaker the way it needs to be. Another neat thing P4A can do here is model swapping. So if we're into our design here and we need to swap out one breaker model for another, or you just put one down for a placeholder, this can easily be done in P4A as well. I'll place down another breaker here, just anywhere in the model space. And when we select our feature, we come up to our feature tree, we can select this icon, and it'll bring up a menu with the other breaker models that we have available. I can select another breaker, and instantly it'll swap it out for that other breaker model that we want. Now, if you notice, this breaker pad appeared. And this is another thing we have available within P4A, and it's called the Feature Constructor tool. And what that can do is that'll say anytime that you place any particular feature down, for instance, in our case, it's a breaker, we can add a rule in the feature constructor that says, hey, place this other sub feature along with it. So I went into the feature constructor and I added this pad to be placed down every time this breaker is added. And we can see that as well too. We'll go back to our circuit breaker when we had before. And if we swap this one out, like we just did again, it'll bring that pad down with it as well. Just a quick side note, some more. There's so much that should be covered, but we only have a short amount of time here, so I'm trying to highlight some of the neat things that I see here. One thing I wanted to notice too, I wanted to point out too, is you see I've got this grid down. It's this 2D grid down in our 3D model space. This is my site skeleton I've laid down, and it allows me to, whenever you're going through your initial layout of your station, you want to create that site skeleton to align, hey, where are the sub bays going to be, where's my transformers going to be, and it just kind of makes a nice grid to align everything up and give you an idea of that 3D surface spatial component to it. All right, so now let's get into some more placements of some geometry here. Let's do some underground work. So I've got a section of trench here next to my breaker pad, and let's go ahead and add conduit down into here. Now this can easily be done in P4A. We've got the conduit drop down in this ribbon here. We can select the type of conduit, its uses, what it's going to be used for, the size. We'll just do you can run conduit with cable already in the conduit that you specify individually. There's a lot of information that could be held within P4A, and it's all how you set up based on your design standards. So we'll go to our conduit knockouts here, and you could tell there are those ports again that we're snapping to. There are two different ports per each knockout here, one in the up direction and one in the down direction. So we want to make sure that we are connecting to the correct port whenever we're going through our design. And again, there's that tooltip that pops up that says, hey, we're going to connect conduit to this pad, this 138 kV generic pad in our case here. So we know we're on the right track when we have that tooltip verifying the connection information. That's what we want. All right, so we'll select on that port. We'll come over to another port in the trench. And then once I run this, it'll show our conduit. Now, it's not exactly perfect, and let me show you why. We've got a little break here. It's showing the conduit going right into the pad. And I did this on purpose to show that we have not entered in any of the model information. We have not modified any of the model data attributes for this conduit run. And that could be easily done in P4A. We'll select the conduit. We'll go over to our dashboard. And there's a section here that is called straight distance from start, straight distance from end, from where we started the conduit run to where we ended it. All the data could be modified here. So I've got some values I'll punch in here. There. And just a little bit of modification, and now we've got our conduit running from our pad to our trench. And this could be done, you could run multiple sections of conduit at a time, you could run single ones, you could run them with cable inside the conduit already based on the design standards that you have. There's a lot of functionality here. So let's go ahead and attach some conductors from our breaker to our disconnect switch here. So what we'll need to do first is we'll need to add some fittings. And in the standard base configuration, it does come with some fittings already available. Of course, you'll want to have your own based on your company's design standards and the material that you use specifically. But here I'll enter in, I'll select a sample. And again, we have multiple ports per feature. Features can have as many ports on them as you need. We're going to make sure that we select the appropriate port. Again, there's our tooltip and the containment icon saying that this double barrel compression fitting is contained by the motor operated disconnect switch. So that's good. We want that tooltip is verifying we are on the right port to connect to. All right, we'll drop that one down. And let's see. It had, let me get rid of that just for a second here. Now we'll add a fitting on the other side of the breaker. All right, there. And then we'll go ahead and run our conductor. In this case, we're going to stick to the 2000 MCM all aluminum. I want my run count to be 2, but we can change that to whatever we need to be since this is a double barrel compression fitting here. Again, with the linear features like conductor and bus, we can connect to ports as well. On this double barrel feature, I can highlight over the middle, and it should highlight both of those ports at the same time. Again, there's my tooltip verifying we're in the right spot. I'm going to select there. And we'll do the same thing down there. We'll get both ports highlighted. Hit enter. And there we have our conductor right there. It is showing a little bit of a disconnect there. That could be modified as well. I think I was messing with the rules earlier and I may have made a mistake there. But what we can do, here, let's try and see if we can get this to work on this side. See if I could do this briefly. Right there. Well, the other compression fitting, again, to these ports, make sure we're on the right port. Run our conductor. Here. It's there. All right, so that's more of what it should look like. All right, so now let's say, hey, we can add, let's go ahead and add one of these, let's go ahead and add one of these Anderson spacers in between here. We can select anywhere along this conductor on both sides, and it'll add a spacer in, which can be modified as well and adjusted to the angle that we need per our design. All right, so at this point here, I'd like to talk about the AUD copy and AUD paste. So separate from the plain AutoCAD copy paste, it's not just going to copy the physical geometry. The AUD copy paste is also going to bring over the model data and attributes that we are copying. And I'll show you here in a second. For this, we're going to go to our top view. Our AUD copy command is up on the substation ribbon. We're going to highlight the features that we want to copy. All right, now it's asking for a base point. I'm going to select this port at the very bottom, at the center. All right, And then I'm going to drag this out and see if I can't insert that onto this intersection right here as well. So keeping it in line with the others. And there we go. Just like that, we have got the same features copied and pasted over on this side as well. Let's go ahead and continue to build this out a little bit. All right, so what we can do here is we're going to add some more of our bus now. All right, now that we've got this ed cap in place over here. So on our conductor, we'll run over to our rigid bus underneath the conductor and connectors. We'll stick with our 4-inch generic bus. We'll select to the port on this expansion fitting. And then what we'll do is we'll highlight or we'll connect to every single piece of bus along the way to keep that connectivity and containment information in place as well. There. We'll digitize the bus section, and there we go. Now we have our section of bus. So SPS does recommend designing small, and with the AUD copy and paste command. So as you're working through your design, you want to make sure, especially in greenfield substations, you want to make sure you build in small, repeatable chunks, verifying your design is 100% correct before using the copy and paste to make sure that you're bringing over the correct model data before continuing on. So now let's talk about adding additional data to the features. So in this case here, I'll use this section of bus that we just placed down. Underneath our dashboard and our attributes tab, there is a whole list of data that can be modified for this feature, this linear feature. Let's just say, let's type in phase. Phase is one option we can do. We can select, hey, is this going to be our A, B, C phase? We can say that this will be on our A phase. This is important when we're talking about reporting and material usage. And documenting our design. We want to make sure that we have all model data attributes completed as we place things down. We can also put in our work order information. So let's say this section of bus is this new work. We can mark it as demo. As you're working through these projects, we can identify what each feature being placed down is part of. For instance, our work order. We can say this is work order number ABC 123, and now we have it documented that in this design, this particular feature is we're working on this particular work order. We know it's new work that's being placed down, and we can track that. All right, so we talked about material and keeping track of that. One of the things that was so very important to me as a sub-design engineer in the past and I was a sub-design engineer for 15 years before moving over to SPS in this space. But we did a lot of not just the engineering element, but project management as well. So it was very important to keep track of the material usage for project scoping and lead times, and you just want to have a good feel for what you are including in your sub-design project. This is where I want to highlight our material editor tab. And what this will do is, as we're designing our site, our substation, it keeps track of all of the material that we've placed down in our design. So you could see here, I'll try to bring this over a little bit. It keeps track of all the material that we've placed down. So for instance, there's our rigid bus. We've got our circuit breaker. As we highlight this, it's going to highlight it in the model space. It shows our quantity, material numbers, the description, the status of our work order. Here's our section of 4-inch bus pipe. There's the work order number associated with it. We can have a part number. Right now it's showing we have 48 feet of that bus. So this is really helpful, especially as a former sub-design engineer, to be able to keep track of the material as you place down, but not just the material, but the quantity. And that's calculated in real time in our model space. This bill of material can be printed, it can be exported, saved off, even placed in model space. Super helpful as we're going through our design to keep track of all of our material. Another thing is our auto validate and auto resolve tools. So SBS does recommend that we keep these tools right here, that we keep these enabled to allow the validation and resolution to operate in real time as we work through our design. Auto validate, and it allows the automatic validation of your design against validation rules as we work. So we can create these rules, and as we design, the auto validate and resolve identify the rules that we have in place, and it attempts to automatically resolve the errors as we work. We do have a tab here, the Validation Rules tab, and if we select that, this is showing all of the alerts, messages, notices that we get as we're working through our design. These will populate from the rules that are based in your design. So right now, this is just saying, this is an alert saying, hey, this trench box here, and you can see it's highlighted. If we hover over it, it'll highlight the different sections in our design. This is saying, hey, we don't have a work order number for this section of trench. That might be something we want to address. And as we address that, these will drop off. There are height checks, there are sizing checks. This is saying there are grounding checks. Hey, this structure here, this disconnect switch is not grounded properly. So the bolt hole sizing. There are a lot of different messages and alerts as we're working through our design that are very helpful to make sure our design is solid and complies with the rules that you have based on your company standards. The next thing I'd like to talk about is our lightning protection and clearance checks. And for this, I'm going to go open up a different file here I have. Now this is more of a full substation. It's a smaller substation, but it is a full complete substation that we have here that I like to show for the demo as well. But for our purposes today, I'm going to use it for our lightning protection. So right up here is our lightning protection command. Now P4A provides this visualization tool that is compliant with the IEEE rolling sphere method. And as we enter this command, it's going to ask us to select our shielding features. So I'm going to select the top of our lightning mast. I'm going to select the finials on our takeoff structure. And when I run this command, it's going to produce that visual here. It's going to produce this visual showing our current lightning protection scheme and how it covers in our design. It's a great sanity check. It's just a great visual tool to show how your current lightning protection scheme is looking. You can see there's a section of bus that is not protected. Of course, the fence, the conservator tank on our transformer, the control house are not protected. So on this particular site, our lightning protection scheme would need to be modified to more adequately protect the site. It's a great little tool, little sanity check on, hey, how's my lightning protection on my site? All right, we'll go back to our main demo file here. The next thing I want to talk about is the clearance envelope. Again, this is another great visual sanity check tool. And the clearance envelope, again, it produces a visual output showing the clearance around linear features, such as a bus, conductor, conduits. And when we run this command, it's going to ask us to select the linear feature that we would like. And now it's asking us down below for the horizontal clearance. So for the demonstration purposes today, I'm going to put 10 feet. I know IEEE standards at 138 kV, 10 feet is way more clearance than what we need right now. But for the sake of the design, I'm going to use 10 feet for the demo to show you. Vertical distance, we're going to say 10 feet as well. And when I hit enter, it's going to produce that visual. So again, great sanity check to show at any particular clearance level, we are seeing that what is within that bounds and what is not. So right now, our switch stand, our bus stands, they are all within that clearance boundary. So if our design did call for a 10-foot clearance, obviously we would have to modify our design here to accommodate that clearance issue that we have currently. Another tool we have is our clearance distance. And this checks for distances between 2 points. And this could be between live points, energized points, grounded or neutral points. We'll select let's say we want to check the distance between our conductor here and our switch stand. So first we'll select our first set of objects, then we'll select the second set we want to measure from. And when we run this box will pop up and it will say that it'll give us our horizontal and vertical distances, but this one right here is the one we want. Between each features, the closest point, 6.449 feet. If we select this, and this is saying, okay, currently the way that these conductors are laid out, and I realize they're a little twisted, we did not modify that after we placed those down. But currently, this exact point to this point on the switch stand is our closest clearance distance at almost 6.5 feet. So you can use this quick sanity check tool again to measure our clearances between 2 points at anywhere in the site. Okay, so now we've been doing all this work in 3D model space, which is fantastic. It has the ability to save us a lot of time based on our rule designs. But you can't take this model space out to the field. You know, as a design engineer in the past, you got to create prints. You got to give something out to the field so they can start to construct the design that we've created. So we need to create some 2D prints based off of our model design. So we've developed a set of really neat tools here using the AUD view create command and a few different commands. We can easily create 2D sheets based off of our 3D model space. So before we get into this, I'm going to go to a top view. And just using a couple commands, we're going to accomplish this. So we'll use a command here called AUD view create. We're going to give it a view name. Let's just call this top view. And we're going to create a box around what we want on our 2D prints. So let's say we want to make a 2D print out of this section of our substation. You can see down below, we've successfully created the view top. All right, so I'm going to create that again, but this time we're going to call this view west. We're going to create a west view site section. It's going to ask us to select the area that we want to create the 2D sheet from. And now it says select the edge from which to view the model. So we're going to select the west side of this box. We select that. Now we've successfully created the view west. All right, now this will all make sense in a second here. Now we've identified the areas that we want to create 2D sheets from. We've made a couple view angles. And now we'll transition over to our 2D paper space. If we hover over the project tab, we see our model space and our paper space. And we can also see it down here as well. So we'll transition over to our paper space. Now here we'll use the command AUD view port create. We're going to create a viewport on this 2D sheet. And you can see here we've got the two views that we just created. Select our top view, place that down, and there we go. Now we've got our section of model space now in 2D space. I'm actually going to rotate this around for the sake of the demo here. Highlight this. We could adjust these 2D sheets to the size that we need to, that makes sense for your particular drawing. We can zoom in. Adjust this here. I'm going to make a few more quick adjustments. All right, now I'm going to run that command again. AUD view port create. And now we're going to do our west view. Go ahead and put this guy in the corner this time. All right. Now from here, we can drag this viewport around to however we need it to be. All right, and just like that, we've got our 2D sectional views based on the model space views that we created. Now for here, we can do some other simple commands to further address the 2D sheets here. I'll create a few center lines. Here, there. We can add we could add a dimension to these. Here. There. All right. We can add dimensions to these guys. We can add different annotations. We can do our callouts. We'll select our conductor here. We can add a callout bubble. We'll do another one. We'll select this feature here. We can even add leaders to these things as well. Here. We'll add more leaders. So we can add callout bubbles. Another really neat thing that we can do within P4A is create the AUD table. So right now I've put callouts on our conductors. So if I run this AUD table creation command, let's go ahead and run a table based on our conductors that we just placed down. If I select that, and I could place this table right in the drawing space. And just like that, it's showing our bill of material numbers. We've got 65, 37. It's showing, there's our work order number that we placed in, ABC 123. It's showing, we have 144 feet of this particular item under this work order, our descriptions. These tables can all be adjusted as well, if adjusted to fit the design right in real time. And before too long, you've got 2D sheets ready to go out to the field. And that is, again, based on any particular part in your model space. So if this were a full substation completely built out, you can create views of any part of your 3D geometry and make them into the 2D sheet space. One other quick note too for AEC firms, you can have multiple 2D sheet views saved for each client without the need to recreate this every single time. They're saved as templates, and it could be saved. You can have those template files saved for each client's CAD standards. We can use the, I didn't show this before here, but we can use the DWG props command, which then we can enter the properties of this particular drawing. Once we complete these and save it, then that will populate our the properties, the drawing properties as well. All right, so I want to talk about, let's get into geolocating the P4A drawing. I'm going to open up another file here. And what we can do is this geolocation really only needs to be done once, and it'll last the lifetime of the station. So just to note, this step is only required the first time you set up a new 3D station layout file. And it can be done with just two commands. The first, we're going to go to this assign coordinate command. We'll run this, and I've already got, for the sake of the demo, something prepared. But we can go ahead and select a coordinate system, assign that to our drawing, and then the second command is going to be the geomark lat long. So we're going to actually put in the latitude and longitude of the site. We want a pin drop on where our substation is going to be in real space. I'm going to go ahead and put in our latitude. Then it's going to ask for our longitude. And again, I've already had something prepared here for the sake of the demo. All right, so just like that, we have now our substation is marked with a exact location on Earth, on the planet, and we can verify that that it's geolocated correctly by using the streaming online maps under the project tab. And when we select that, it'll pull in, we'll select the map type here. It'll pull in the map based on that exact pinpoint that we just set up in this step. So as you can see here, let's just say, hey, this is the site for our new substation. We've got the pin laid down. Now we can start building right on top of this location here. This is a good point to show another command. I want to talk about the XREF command, the external reference. So on that original demo file I showed over here, I had the site skeleton down. We can do the same thing by using the XREF. So if you have a site skeleton, a 2-dimensional layout of the substation, we can bring that in using the XREF command. We'll select that here. This box will pop up. It'll talk about the scaling, the insertion points. I'm going to specify on screen where we want this to go. So I'll go ahead and leave it all defaults. We'll hit OK. And then what it is doing is it's going to pull over that site skeleton. I know it's kind of hard to see with that the color schemes currently, but we can place this guy down right on top of our map, the map imagery. And so from here, we can start building out our substation. We can start attaching to these lines and snapping things in place. And right on top of the geolocated maps. Just a quick note about that XREF command. It's dynamic, so any changes made to the remote file, so as if you were to modify this externally referenced file remotely, it will get synced in almost real time, providing instant updates, which is fantastic. So you can have someone working on that separately and have it update your main project design instantaneously. And another big part about the XREF command is these XREF drawings are not actually part of this drawing, of this model space that we're working in now. They're just attached to the drawing, externally referenced. So the big advantage is it doesn't increase the file size of the base design. All right, so let's talk about civil 3D surfaces. We've got this map here and everything looks flat, but let's say you have a site that's not perfectly flat. I know in my sub-design days, there were sites where they were tiered. There'd be sections of the sub several feet higher above the rest. It just depends on the geography at the location. So you want to make sure that we can take into account our civil 3D surfaces. I'm going to create a few points using the point command to accomplish this. And I'll just drop a few of these down. Maybe one in the middle, over here. These points then can be modified. So let's say these two are at, if we over here in our properties panel, we have the Z elevation. Let's just say, hey, this is 5 feet up. And this one is, let's say 10 feet. I know that's pretty dramatic, but for the sake of the demo here, it provides a nice visualization. We'll then go to our create surface. We'll highlight all of our points. I'm going to deselect the XREF site skeleton in our point here. And when we run this command, it will then create a civil 3D surface of our site. Now you can tell here that it is elevated. Again, probably not practical in real life, but just to show what the surfaces can do here. And you still have the capability to work on your site skeleton as well, and take advantage of different heights at your site as well. Any fencing that we put around this, that we can connect fencing to these points, and the fencing will change as well. It'll adhere to the 3D surfaces that we've created. All right, now I want to get into another new command. It's called the AUDEXTRACT command. This is a newer command, and I have found this command to be extremely beneficial, and especially reflecting back upon my sub-design days as well as a design engineer. A lot of times you'll have multiple projects going on at a particular site, and so if you have one main project file open and you've got multiple hands in that cookie jar trying to save on top of each other, and it can get convoluted pretty quick. So this AUDEXTRACT command in P4A, it's a P4A command that allows multiple designers to work on small different sections of a substation at a time while extracting and updating each of their changes back to this main 3D station file. Very useful when you talk about multiple projects being done at a site at one time. And this can be done easy in P4A with just a few commands. First, we're going to establish a boundary. So we're going to use the AUD boundary command. And we're going to draw a boundary around our particular site where we're working. So let's say this is a larger substation, and we have been assigned as the design engineer to work on this small particular section of the substation. We're going to do some work within here, but we don't want to work in the main 3D project file. We want to work kind of off to the side, but also send updates in real time. That's where this AUDEXTRACT command comes in perfectly. So we've created our boundary. Now we're going to edit that boundary, AUD boundary edit, select our boundary, and then we're going to select within. So this will grab all of the elements within that boundary, all of the features. We can even highlight them to show we've got all these features highlighted and selected within this boundary. The next command we're going to use is actually our AUDEXTRACT command. The first thing we have to do after we've created that boundary is establish a link. So we're going to select the boundary, select the drawing that we're going to be working from off to the side. I've already have one here prepared, just a blank drawing. And then we're going to set down this link location in this boundary. And what this is going to do is when we go to open up the other file, it's going to look for this link that we just created so it knows which boundary space it's working in. Because you could have multiple boundaries set for a larger substation, you know, if you have multiple projects at a site at a time. So we've created our boundary, and now let's go ahead and open up our drawing. The other drawing that we're going to work on from within this boundary. All right, so we're going to a separate file now that we're going to work on making changes to the main station file. So again, once we're here, we'll use that AUDEXTRACT command. We are going to select extract. Now this is where that link file comes in handy because it's asking us for an extraction source file. That's going to be that main project file that we had that we put that link down in. I'm going to open that up. And you can see we've extracted 23 features into this drawing here. And here they are right here. Now you can see that the visualization is a little different. Right now it is showing our geometry in more of a wireframe, a 2D wireframe mode. And I should have mentioned this earlier, but there are multiple visual styles within P4A. SBS does recommend working in the 2D wireframe to enhance performance. We could do the shaded with edges like we had before, and I'll select that. In this small example, we're not dealing with much geometry, but if you had a full substation like that other demo, your system performance is more affected by using the current visual style we're showing here. We can also change those visual styles using an AUD fidelity command, which will change it from more detailed to more simple blocky geometry as well. Like you see here with the sheds on the insulators, it's more of a cylinder as opposed to showing the individual sheds. This is a different fidelity than the switch insulators there. All right, so back to the AUDEXTRACT command. We've got our file open here. We're working on a small section of our station. Let's say we're going to make some changes. We'll just remove the breaker pad. We'll remove the underground conduit. So we've made some changes to our remote file. Let's take this back to we'll go back to the main 3D file. And now that we've made those changes, what we can do is back at the main 3D file at any particular time when you have multiple designers working on different sections, we want to check their progress. We want to see what's been done within that boundary we created. Well, again, AUDEXTRACT command. We'll run that command and there's an option to update. So we'll select update. It's going to ask us to select the boundary feature for extraction. Again, there could be multiple boundaries based on the projects going on at a substation. So when I select this, it should automatically update all the work that's been done on that remote file. So you can see the boundary disappeared, or the pad disappeared, our conduit disappeared, and this allows, again, multiple designers to work on one substation at a time without stumbling over each other in the main project file. There are countless commands and parts to P4A that we didn't even get into. I've got less than 5 minutes here on my time, so I want to allow some time for questions. But some of the things that we didn't cover was creating the 3D geometry models using our part builder SBS. We do have a utility content site where you can download some of these pre-designed models into the P4A space. There's AUD workflow command where we can add, for instance, like A-frames from high to low buses that are already pre-configured. You run the command and then the A-frames automatically attach. We didn't get into ground grid creation or the rules editor themselves. There's so much more that can be talked about here in P4A, but you see how quickly an hour goes by so fast. And I'd be happy to explore and talk about this more going forward in the future. But at this point, for the sake of time, are there any questions that we have in the chat? I know I'm about 3 minutes to the hour. If there are no questions now, you can also email me at any time and at daniel.luck@spatialbiz.com, and we can address those questions. Oh yeah, the feature constructor. I wanted to show you one more thing here too. There's so much to this in such little time, but if we go to our configuration tab and the table editor, here is that feature constructor I mentioned where we talked about if I have this particular model, for instance, that breaker, that smaller breaker I showed at the very beginning, it's saying use this subclass and subfeature model. So anytime this breaker is placed down, it's going to place down this particular pad at the port names and the port locations. I'll show you really quick the part editor where we go to define ports. So if you go to the part editor, we have all of the parts here. I'll go to that circuit breaker, select this guy, and this is showing all of the ports attached to this circuit breaker model here, showing their names. We can name them individually to show in our model space, the exact geometry, the locations of where these ports are at. All of this information can be edited, modified from our utility content site. You can pull in new geometry and assign your own ports and all the information based on your design standards. There's so much to cover. An hour doesn't do it justice. And let's see, I do see we have a question. Let's see, for civil aspect, would using certain layout for FEMA flood zones work? I know that could be an issue for certain sites. Yes, absolutely. So yeah, that is very important. So we can create points at any elevation. We can create that civil 3D surface, and it could be for any particular. When we set that geometry, you can set that location to point to, to any specific spot wherever your sub is at. You can create that civil 3D surfaces and work around, go no go locations. Again, I appreciate all of you guys being here, and I hope you guys have a great rest of the day and week.